kiddos, welcome back. Today we're talking about Chapter 1, Section 2, Day 1. Okay, today we're going to be measuring and constructing segments. But before we get started, we have some definitions to go over. So our first definition is postulate and axiom. These two words in geometry means that there is a rule in geometry that you can accept with no further proof. You do not need to prove it every time, okay? Going along that, we have something called the ruler postulate. So imagine a number line where I would make the middle 0 and then count up on one side and down the other. And I could put a point here and a point here. Now, how do we use this as a ruler? What's the difference between these two things? Well, you take the bigger one and subtract it from the smaller one. But we'll get into that in a minute, okay? So, the real number that corresponds to a point is called the coordinate. So when I drew that point, so if I give this a 0 and this a 2, if I drew a point on 2, then that is the coordinate. The coordinate is at 2. Okay? The distance between points A and B. So again, if we have a segment at A and B, the distance, so how far it is between those two things, that is called just AB. So if you were naming this segment, it would be capital A, capital B with a line over top of it with no arrows. But since we're not naming it, this is just the distance. It's AB with no lines. Okay, so let's say that this A is on 3 and this B is on 7. Okay, so the way that we would do that is we would take, so AB, the distance, is equal to the absolute value of 1 point, so 7, minus the other point, 3. Then your absolute value bars, 7 minus 3, that means AB is the absolute value of 4. And the absolute value is just how far is it from 0. And 4 is 4 units away from 0. So the absolute value of 4 is just 4. Okay, and you're probably wondering, what if I pick 3 as my first point and 7 as my second point? Well, that's okay too. You'd actually get the same answer. Again, if we do AB equals the absolute value, and this time I'll put 3 first, minus 7. 3 take away 7, that'll leave you with a -4, the absolute value of a -4. And if we look at a number line where 0 is right here, and we count -1, -2, -3, and -4, -4 is still 4 units away from 0. 1, 2, 3, 4. So the absolute value of -4 is still 4. So you get the same answer both ways. The next thing we're going to talk about is called congruent segments, okay? Congruent means the same length. So if we were looking at AB, and again, I'll just use 3 and 7, and we already found that this distance was 4. So if I say this one is 12 and this one is 8, let's do this distance. Let's find this distance. We have CD with no lines over it because we're talking about the distance equals the absolute value of 1.8 minus another point, 12. 8 take away 12, that gives you -4. And like we just talked about, -4 is still 4 units away from 0. So the distance is 4. So this distance is 4. So the distance between C and D is 4, and the distance between A and B is 4. So that means that these two segments are congruent. They are congruent segments. If you have congruent segments, there is a special little symbol that we use to show that they are congruent. And that symbol looks like an equal sign with a little squiggle on top. So if I wanted to write it out, I would say that the distance between A and B, again, I'm talking about the distance, so we're not putting a line over it, is congruent to the distance between C and D. Next, we're going to talk about being in between something. And being in between is when 3 points are collinear. Remember, we talked about that those mean on the same line, that there is a point between the other two. Okay? So that would look like if you had a segment between A and B, there is a point C in between them. So being in between them means being in the middle of those 2 points. So C is in between A and B. When a point is in between 2 other ones, we can use something called the segment addition postulate. So I'll write that down. The segment addition postulate. Okay? And so what that means is, I'll give an example that B is in between A and C. So that means that A and C are our endpoints. A and C. And B is in between our end. B is in between A and C. Okay? So what the segment addition postulate says is that if you take this first segment between A and B and add it to the second segment between B and C, you will get the whole segment between A and C. First chunk plus the second chunk equals the whole thing. And it would look like this if I wanted to write it out. The distance between A and B, so there's no line, plus the distance between B and C, so again, no line, is equal to the distance between A and C. And let's do one more example of this. Okay, so if I draw a segment and I say that point A is in between points M and C. Okay, so that means M and C are on the outside and A is somewhere in the middle. So if we look at the example, point A is in between points M and C. That means points M and C have to be our endpoints. And that means A gets to be somewhere in between M and C. Okay, and if we wrote a segment addition postulate for this, it would be the first chunk plus the second chunk equals the whole thing. So that would be the distance between M and A, so no line over top, plus the distance between A and C, again, this is distance, so no line, equals the distance between M and C, so the whole thing. So first chunk plus second chunk equals the whole thing.